All right, welcome. In this video, we're going to be continuing to practice our 3x3 systems. We're going to work on homework 2.2b, which is really just more of the same. Okay. The only thing new really this time is that, there might be infinitely many solutions, but you're already familiar with that from the 2x2 case, and so let's just get to it. All right, so this one's got f plus g plus h equals 13, f minus h equals -2, and -2f plus g equals 3. I think what I'm going to do is I am going to substitute on f in this one and that one. I'm going to solve for this f, so I'm going to add an h to both sides, and I'll say f equals h minus 2. And then I'll be set to do some substitution. Use a separate sheet of paper because I already know that this is not spaced out enough for how large I write. Okay, so f equals h minus 2. So I'm going to go over here and substitute in the first equation. So f is h minus 2 plus g plus h, that equals 13. And then in the third equation, I've got -2 of f, which is -2 of h minus 2, plus 1g is equal to 3. Now I've got a two-variable, two-equation system that I'll be able to solve. Okay, if you've done elimination, it would work. It's just a little confusing, because you might subtract this one minus that one or something, and you'd feel like you were worse off than you started because you eliminated g, but you incurred or you eliminated f, but you incurred a g, and so I just don't want you to be confused. My recommendation on these, just use substitution, right? They're pretty well set up for it. So I'm going to start collecting like terms. This is just going to be h minus 2 plus g plus h equals 13. So that would be 2h plus g. And I could add 2 to both sides of this equation because it's just going to be 2h plus g minus 2. That's going to equal 15. Is that just barely visible to you? All right. Then I could distribute over here, and I'm going to need to kind of keep track here. -2h plus 4 plus g. So I would subtract a 4. That's going to equal 3. And I would subtract 4 from both sides of this equation, and I'd get 3 minus 4 is -1. So I'd have -2h plus g equals -1. Oh, yep, it's all right. Okay, I was not expecting this one to come back no solution. I don't think I intended for I thought the first one was supposed to be a unique solution. I think it's going to be. Let me just double check this. -2h plus g equals -1. We're going to add these together, okay, and that's not going to cancel, right? If I'd seen -2h minus g equals -1, that would have been no solution. So I'll add these together. I don't need to do anything to these equations, and I'll get 2g equals 15 minus 1 is 14. So that gives me, okay, divide by 2, g equals 7. Okay, you can see it now. All right, and then I'm going to need to plug into one of these equations. I kind of like the look of 2h plus g equals 15. I'm going to substitute on g. 2h plus 7 equals 15. Hey, well, you could look at it and say, okay, that means 2h needs to equal 8, or, because 8 plus 7 is 15, or you could subtract 7 for both sides. Either way, you'll get 2h equals 8, and then h equals 4. Okay, that's my second value. Now, to get my third value, I should probably go in, I want f. Oh, wait, I've got a formula because I did substitution. Go back to that. F equals h minus 2. F is going to equal 4 minus 2. So I've got f equaling 2 right there. Okay. And that was number 1. All right, number 2 here. This one looks like I'm thinking probably elimination on x. Yeah, using that -1x as my tool. I could also eliminate on y. I could eliminate on z if I wanted to. Kind of like the look of eliminating on y a little more. Because I'd rather multiply by 2 and 4 than 4 and 5. Yeah, but if you want to eliminate x, you go ahead and do that. Do whatever you think you should do first. All right, so I'm going to eliminate on y. So if I label this one equation 3, this one equation 2, and this one equation 1, I'm going to need 4, 3. Yep, so that'd be -4x plus 4y plus 8z equaling -12. And I want to add that to equation 2. Yes. This may actually just be happening sooner than I expect. So 4 equation 3 plus equation 2 to eliminate on y is my thought. And I'll say equation 2 is 4x minus 4y minus 8z equals 2. I'm going to add these together. I'm going to get 0 plus 0 plus 0. That's all going to equal 0 equals negative 10. That's unlikely. Okay, I see something that's patently false like that. I know this is a no solution scenario. Okay, good that we ran into one of those pretty early on, I think. All right, number 3. Keep using this piece of paper, I think. And I'm thinking we can eliminate on x. Yeah. So I'm going to do equation 1 minus equation 3. And then I'll take equation 1 and scale it up by negative 2 and add it to equation 2. All right, so equation 1 and negative equation 3. Yep, here we'll see that. So equation 1 I'm not changing. Negative of equation 3 is negative x plus 4y minus z equals negative 18. Okay, add them together. I get 0, 6y, negative 3z. Equaling, add them together, negative 33. Okay, that's fair enough. We can work with that. Then I'll want negative 2 of equation 1. And then I'll add that to equation 2. Negative 2 of equation 1 would be negative 2x minus 4y plus 4z equals positive 30. Not visible. If I zoomed out, yeah, that'll work. And then, okay, where am I? Here, and I'm just copying in equation 2, 2x plus 4y minus z equals 8. Wait. No, that's, I had copied wrong. Okay, I'm supposed to directly be copying equation 2, and that was equation, or part of equation 3, yeah. 2x plus 1y, so 4 didn't have any business there, minus 5z, so I need some more room to put in a 5 there, equals negative 21. Add these all together. And I'll have nothing, negative 3y minus a z is equal to, just making sure I didn't make any errors, because I was expecting this to come back. I don't know what I'm expecting to happen here, actually. That's going to be 9. Yeah, this one must not be. It's definitely not no solutions or infinite eliminating solutions because these lines aren't parallel, right? Or if they were lines in the YZ plane, they wouldn't be parallel. So I'm going to go over here and I'm going to set this up. I'm going to probably double this one to set up for elimination on Y. So I'm going to say, all right, negative 6y, I'm just doubling everything, minus 2z equals 18. Okay? I'm going to add these together, 0, negative 5z equals negative 33 plus 18 is negative 15. That means that z is going to need to equal positive 3. Okay. From there, I'm going to go back to one of my 2 equations. I kind of like the look of 6y minus 3z equals negative 33. Okay, I know that negative 3z is going to be negative 9. Okay, so if I added 9 to negative 33, I'd have, I think, negative 24. Okay, that's a good sign. And I'm going to divide both sides by 6, and I'll get y is negative 4. Then I'll go back to one of my original equations. How about x plus 2y minus 2z? So x plus 2y minus 2z needs to equal negative 15. Okay. I know what y and z are, so x plus 2 of negative 4 minus 2 of 3 equals negative 15. So I just need to clean some stuff up. X minus 8 minus 6 equals negative 15. All right, so x minus 14 equals negative 15, and if I added 14 to both sides to get at x, I'd see negative 15 plus 14 is negative 1. And that looks good to me. X equals negative 1, y equals negative 4, z equals 3, and I did elimination on that. All right, paper's filled up. Let's keep it moving on. So number 4. So I'm liking the look of this for elimination on x. Yeah. You could substitute on z though, right? You could say z equals x plus y minus 6, and then, substitute on z. If you're a big substituter, that's what you should be doing, right? Because a lot of these are very substitutable. And I'd say really the only one that I would really, really discourage you from substituting on is one where I haven't seen one. I did one in the examples in class today, where basically all of the coefficients of x, y, and z, none of them were 1, and so that would involve a lot of fraction arithmetic, and I don't recommend that because I know that that's a place where we make errors. Okay, I would recommend on this one, you could go either way, but I'm thinking elimination on x. So equation 1 plus equation 2, I'm just going to copy them. Zero, 1y, negative 2z equals 2. Okay, then if I was to do 2 of equation 1 and add that to equation 3, that would kill off the x's down here, right? That would become 2x, and then that would add back to 0. So that would be 2x plus 4y minus 6z, not off the shot yet, equals 16. That's 2 of equation 1. And then equation 3 is negative 2x, negative 3y, and positive 4z equaling negative 14. Okay, when I do that, I'm going to get down to something like 0 plus 1y and negative 2z's equals 16 minus 14 is 2. Since I'm seeing the same thing here and there, my new system is y minus 2z equals 2, and y minus 2z equals 2. So if I was to subtract one from the other, I'd get 0 equals 0. And I know that that means I am looking at an infinitely many solutions situation. That's number 4. All right, let's move on to the back side now. All right. Lots of more examples. All right, number 5. 2x minus y plus z equals 4. X plus y minus z is 11. Let's eliminate y. Okay. We could definitely eliminate z. Z is no better or worse than y because I've got one negative to go with that positive and then a 2. But I'm thinking I'm going to use this positive y, double it, add it there. So I'm thinking plus equation 2. Add them all up. That's going to be 3x. The y is canceled. Oh, the z's canceled as well. That is very fortunate for us, right? Because now I know if 3x equals 15, I can divide both sides by 3 and see that x is going to be equal to 5. Okay. Now, you don't want to get ahead of yourself at this point. What I should go is stick with my plan of eliminating y. Okay. And then, I mean, you don't know what's going to happen, but don't change your approach. Just, because I discovered one. Good for you. That's great. But really what we have is 3x plus 0y equals 15, and we're going to have some other thing over here. And that will help us find our second one. So don't lose sight of the prize. We are going to take 2 of equation 2 and add that to equation 3. And that's going to give us something else that hopefully I can use that x equals 5 on. So 2 of equation 2 is 2x 2y negative 2z equaling 22. And then 4x minus 2y plus 2z equals 5. That's not a good sign. Okay, I think that means that I just like kind of had some unfortunate luck when I did my elimination, and because I'm going to get two different values for x, and that's not a good sign. That must mean no solution. Well, hold on, let me just think about this real quick. Probably should have paused, but yeah. Okay, let me make sure I didn't make an error. 2 of equation 2, 2x plus 2y minus 2z equals 22. Yeah. 1 of equation 3, 4x minus 2y plus 2z equals 5. Adding them all together, I'm going to end up with 6x, 0, and 0 equals 27, which is not 5, right? If this was 30, yes, definitely. Okay, and so I believe that this one's going to come back no solution. And I think it would be easiest if I had 3x plus 0y equals 15, 6x plus 0y equals 27. Okay, I think it'll be easiest for you to see why this is actually giving me no solution. If I had 6x plus 0y equals 27 and 3x plus 0y equals 15, well, I'd want to multiply the second equation in red by -2. So I wouldn't change this, but I'm just multiplying everything by -2. So that when I go to eliminate x on this, I'm going to get 0 equals -3. And that's where I'm seeing no solution. Okay, being honest, y'all know I haven't taught Algebra 2 in a few years, but I do teach linear algebra where we do a lot of solving of systems of equations. And this type of scenario doesn't come up in linear algebra because we're looking at a matrix, and the solution always looks the same on a matrix, which is something that we will talk about later on in this course, like in the spring once we start using technology. But this one was a little tricky, but like I said, don't lose sight of what you're doing. Right, you're doing elimination to get it down to a 2x2 system, But I guess if you get two different values for x, that's going to be evidence of no solution as well. Yeah, I think that's all I'm going to say about number 5. That one just kind of jumped out of nowhere at me. But, that's going to happen when you jump in and teach a course that you haven't done in 6 or 7 years. Yep. So this next one, maybe this one will come back with a unique solution. I'm ready to just take one all the way too. So here's one that would probably not be ideal for substitution, right? Because there's just going to be, you could solve for x and everything, but it's just going to be, less than ideal. I think what I'm going to do, I'm going to eliminate. And so I'm going to say 2 of equation 2 plus equation 3, get 2x and -2x there. And then equation 3, just copy. Okay, 0, 7y, 2z. What's that going to be? 28, I think. Okay, and then I'll go over here, and I'm eliminating x, so I would take equation 1 and -3 equation 2's. Scoot down a little bit so you can see. Equation 1, I'm just copying. 3x minus 2y plus 5z equals -14. And -3 of equation 2 would be -3x, -15y, and positive 9z equaling 18 times -3, that's -54. So when I add this all together, doesn't look good. Oh, okay, I see a path forward. -17y. Let me just make sure. Equation 1, -3 of it. Oh, no. Okay, yeah, there it is. Really, 17, that's a pretty bad number. But that's not what it's going to be, because I made a mistake when I scaled up -3. Oh, nope, that's -3 of equation 2. That is -15y plus 9z. Okay, 17 is a bad number, but I have faith it's going to work out. Okay, I've worked enough of these. And even if it doesn't work out, I'm ready for that too. Add these together, I get -68. Okay, and I've got that 14z and that 2z here, so I'm not going to have to multiply this by 7, because it's like 7 times 14, that's 98. I can do that. 7 times 68, that's asking for an error, right? And then multiplying 28 times 17, yeah, forget about it. I don't have that. I'd have to pull out a calculator, engage in some long arithmetic, and you shouldn't really be needing to do long arithmetic in this course, right? Outside the comp test. But, all right, let's multiply this one by -7. That's going to be a stretch, but negative 49y minus 14z equals 28 times 7. Well, 20 times 7 would be 140, and 7 times 8 is 56, so I'm seeing a total of 196. I'm going to hope this is right, but I am doing this without these calculator, right? That's the whole point. So I'm going to then copy this one in. Negative 17y plus 14z equals negative 68. Just as I got done saying you shouldn't need to do long arithmetic here, let's add them together. 49, 59, 66. Okay, well, 196 minus 60 would be 136, and this is going to be 128. Yeah, I'm with that. Hold on, I'm concerned. All right, I have looked very closely at my work. I am not able to figure out what I'm doing wrong. I cannot identify the error. If you have identified the error I've made, please let me know. Like, come see me tomorrow, or just let me know before class on Wednesday or something, or whenever, you know. But what I'm going to do, and this is what you should do as well, if you, I don't know, I looked up the answer on using technology, and while you don't know how to do that yet, I'm sure you know how to use google.com, right? And you can look this up. And if you're not getting the right answer, start from scratch. So I'm going to take this paper that I was working on, toss it, that one's out. I'm going to try something different. I'm going to use substitution. It's not going to be any different. There's going to be some bad distribution, but I haven't done much substitution lately, and I always neglect to do substitution examples, so I'm going to do it. I'm going to solve for x. X equals, I'm going to subtract 5y, add 3z, and then keep that 18 there. Okay. So if I want to do 3x minus 2y plus 5z equals negative 14, I'm going to have 3x minus 2y plus 5z equaling negative 14. And then I'm going to distribute all this. So negative 15y plus 9z plus 18 times 3 is 54. I did check that on the calculator too. I checked all the arithmetic I did, and I couldn't find anything that was wrong, so I don't really know what's going on there. Minus 2y plus 5z equals negative 14. But I've moved on, right? I'm doing substitution. I'm doing something different. So what I need to do now is collect like terms, and that'll get me one of my equations. And I'm going to just write the two equations in red. Okay, so on y's, I've got negative 17y plus 14z. And I'm not going to go dig it out, but I feel like these had the same sign last time I did this. So it must have been a sign error. And then if I take negative 14 and I subtract 54, I'm getting that same negative 68. Okay. And then if I do substitution on the other one, I'll have negative 2x minus 3y, I'm just doing this on equation 3, plus 8z equals negative 8. And then when I do the distribution, I'll have positive 10y minus 6z minus 36 minus 3y plus 8z. That's going to equal negative 8. And when I combine like terms, I've got 10y minus 3y is 7y. 8z minus 6z is 2z. Negative 8, and I add 36. That's where it's going to be. I don't know. I'm feeling very tempted to pull up my old work, but 36 minus 8, that's going to be 28, right? 36 minus 8, yeah, okay. So I'll make sure once I've already made an error. I've just been talking big about how I was doing this without the use of the calculator. That is the exact same system I had before. Okay, so I must have made an error somewhere after that. Unless I just keep making the same error, which is definitely possible. I'm going to work this one more time. I know what I'm supposed to get is, I'm supposed to get integer values for x, y, and z was what I looked up, and I'm not seeing that happening, but we'll get there. All right. Now I'm going to take these two red equations and turn them into their own 2x2 system. So I'm just going to copy. Negative 17y plus 14z equals negative 68. And now I'm going to take 7y plus 2z equals 28. And I'm going to get this so it's got negative 14z. Okay? So I'm going to multiply everything by negative 7. So I've got negative 49y minus 14z equals negative 28 times, or 28 times negative 7. Oh, that must be where it is. I don't remember adding. Oh, no, I hate to spoil all the fun for you from the second semester. It's 28 times 7, right? Yeah, that's what I want. It's negative 196. That's more like it. Okay, now when I add these all together, I'm going to get 0. That's negative 66y equaling, all right, all of this, that's going to be 264, I think, negative 264, yeah, because if I borrowed 4 over here and added it, I'd have negative 200. Negative 200 plus negative 64 are going to be negative 264. And this divides evenly, finally, okay, y equals positive 4. Okay, I'm not sure what happened the first time, but I'm just happy because I got myself an answer. Okay, 7y plus 2z equals 28. I'm going to go over here with that to find out what z is. 7y is 7 times 4. That's 28 plus 2z equals 28. Let's solve that one with our eyes. Z needs to equal 0. All right. Then, lastly, all right, yeah. I've got an x equation up here. So I'm going to say x equals negative 5y is going to be negative 5 times 4 is negative 20, plus 3z, well, that'll be 0, plus 18. So negative 20 plus 18, x equals negative 2. Negative 2, 4, 0. Is that what I got? That must be a different one. Oh, I cleared that one out. So, yeah. I'm going to take it on faith. I've spent enough time on this problem. I've floundered enough. Only got a few minutes left in my work day. So that was just number 6, wasn't it? Okay. I'm thinking I'm going to try to finish. I think I can do it. Hopefully no other catastrophic errors on this one, right? That's, if I can avoid that, I would like to, yeah. Have I already done this one? Negative 15? No, okay. It's similar to one that I've already done, but all right. I'm going to eliminate on y. Okay, so equation 1 plus equation 2. Even still visible to you? Not at all. Okay, equation 1, I'm going to go a little faster here. 2x plus 1x is 3x. Plus z minus z is nothing. 4 plus 11 equals 15. Okay, that's great news for me. X equals 5. Okay, but I'm not going to lose sight of what I'm doing here, and I'm going to continue to eliminate y. And I'm going to double equation 2 and add that to equation 3. Okay, so when I do 2 of equation 2, I'd have 2x plus 4x is 6x. 2y minus 2y is no y's. Negative 2z plus 2z is nothing. And 22 plus 5 is 27. I did do this example already. I got x equals 5 and x equals 27 over 6. Yes, because I needed to go to number 7. I'm just really having a tough time right now. Pardon me. I'm sure you're watching this. This guy has no idea what he's doing. And right now, maybe I don't. But in general, okay, yeah, I even got fooled here. I can see it looks the same too. Am I still wanting to eliminate on y? Yeah, definitely. All right, so I'm going to take 2 of equation 2 and add them to equation 1. Okay, so 2y and negative 2y is going to add to 0. 3x and 2x is going to be 5x. 4z minus 6z is going to be negative 2z. 2 of equation 2 is 2, plus equation 1 would be 8, is going to be 10. Okay. Then the other equation, I'm going to do 4 of equation 2, and add that to equation 3 to, again, eliminate y. So 4x plus 6x is going to be 10x. 4y minus 4y is 0. Negative 12z plus 8z is going to be negative 4z. And 4 of equation 2 plus equation 3 is going to be 4 plus 16, that's 20. And maybe you notice that these are the same equation, just one is scaled up by the other. Or maybe you don't, and you want to double this one. So I'd have 10x minus 4z equals 10, and maybe you make this one negative. Negative 10x plus 4z. Oh wait, if I doubled this, I would need that to be 20. Equals negative 20. And I add it together, and I get 0 equals 0, and I know that's infinitely many solutions. Okay, that's great. That didn't take so long. Number 8. Okay, let's eliminate on y. Yeah. Let's use the negative y in equation 2 as our tool to clear out the rest of the y's. So equation 1 plus equation 2 is going to be 1x, 0 y's, and 3 z's, equaling 2 plus 7 is 9. Okay. Then, to clear out the 2y in equation 3, I'm going to do 2 of equation 2 and add that to equation 3. Okay, so negative 2x minus 3x is negative 5x. Negative 2y plus 2y is 0. 4z plus 3z, that's going to be 7z. And 2 equation 2's is 14 and 7 is 21. Okay. I think the suitable thing to do here is scale this up by 5, so I have 5x and negative 5x. So I have 5x plus 15z equals 9 times 5 is 45. And then I'll just copy this one, negative 5x plus 7z equals 21. Yep, this is going to work out nicely. Get 0, 22 z's, and that's going to be 66. And that means that z is equal to 3. Okay. Then from there, I'm going to go back to x plus 3z equals 9. So that's x plus 3 times 3 equals 9. So x plus 9 equals 9. What do I add 9 to get 9? Oh, yeah, x equals 0. Okay, I've got z equals 3, x equals 0. Now I should go back to one of my easiest looking equations at the beginning. 2x plus y plus z equals 2. So y plus 3 equals 2. I'm going to subtract 3 from both sides. Equals negative 1. Okay, great. 2 more. Can I do these in just 5 to 10 minutes? I hope so. Okay, this one. This looks like a substituter to me. I think I'm going to, substitute on x. Right? Now, you can do elimination if you want. I'm just wouldn't totally recommend it, with z and y and everything. So I'm just going to solve for x because I've got x in both of the other 2 equations. That's why I want to substitute on x. So x is going to equal negative 2z plus 11 when I subtract 2z from both sides of that first equation. So 2x plus y equals 4. So that's negative 4z plus 22 plus y equals 4. Okay, so to collect this all together, I've got my first equation is y minus 4z. If I subtract 22 from both sides, I'd have negative 18. Okay. Then when I substitute into x plus 3y, so negative 2z plus 11, that's x, plus 3y plus z, that needs to equal 1. So what I'm going to need to do is combine like terms, and I'll get 3y minus z. I'm going to subtract 11 from both sides, and I'll have negative 10 over here. Okay, that's good. So what I'm going to do, I'm thinking I might multiply the bottom equation by negative 4. So I'd have y minus 4z equals negative 18. And then this one's going to go by negative 4, so negative 12y plus 4z equals positive 40. That doesn't look good. Doesn't look good at all. Okay, what am I missing here? Negative 11y equals, oh, no, it's 22, not 12. Okay, that was very concerning. So not that all answers need to be integers or even nice rational numbers, but in this class, I mean, it's a good place to stop and check your work if it's not going well. So I'm getting y equals negative 2. Okay, that's my first result. So I'm going to go back over here. Y minus 4z equals 18. So negative 2 minus 4z equals negative 18. I'm going to add 2 to both sides. And I'll say, okay, if I divide negative 16 by negative 4, I would get 4. And then I substitute on x, so I should have a nice formula for x. It's right there. X equals negative 2z plus 11. So negative 8 plus 11, that's going to be 3. Okay, so I'm going to say x equals 3. All right, and I've got one more, and I am going to finish it. Okay, this one I need to eliminate on z, right? Look at these numbers. 3, 4, 5, we don't want to do that, right? 2, 3, 3, we don't want to do that either. But we're going to use that negative z, so I'm going to start off with equation 1 plus equation 3. And I'll have 4 and 3 is 7x, no y's, no z's, equaling 7. Okay, love when that happens. Okay, then I'm trying to eliminate z, right? So I need 2 of equation 1 plus equation 2. And that will give me 2 of equation 1, 8 and 5 is 13x. 2 of equation 1 plus equation 2. Negative 6 plus 2 is negative 4y, and 0 z's. 2 of equation 1 is negative 6 plus 7 equals 1. Okay, well, I already know x is 13, so I've got 13 minus 4y equals 1. Okay, if I subtracted 13 from both sides, I get negative 4y equals negative 12. And then I divide both sides by negative 4, and I get y equals 3. So that's 2 of my 3. I go to the easiest looking equation. I like the bottom one. 3x plus 3y plus 3z equals 10. 3x plus 3y plus 3z equals 10. I've got 3 plus 9 is 12 plus 3z equals 10. I'm going to subtract 12 from both sides. And then I'll divide both sides by 3, and I'll get z is negative 2/3. That's not that bad, and that was a long set of practice problems. Okay, and I hope these solutions helped, and thanks for watching.